Hello, everybody, and welcome to another episode of the Red Effect Podcast. I'm your host, Coltin Schachtner, and today we have a special guest, Becky with the National Weather Service.
Good morning, afternoon, whatever it is.
Yeah, whatever time of day it is, it's hard to tell in here. So you're here for one of our all-in meetings, and so we're going to have you talk here before for those who couldn't make it. So can you describe a little bit of what you do with the National Weather Service and NOAA?
Yes, so we are under the Department of Commerce. And then under that is NOAA. So within that, for water, there's fisheries and oceans, all kinds of water things. And then we are the land portion, so we just forecast the weather. We do, our primary job is severe thunderstorm warnings, tornado warnings. We cover the eastern Nebraska, southwest Iowa. So the Omaha office has 38 counties in total. And then Hastings office to our west, Sioux Falls to our north, and so forth. So any weather that comes in those 38 counties, whether it be from snow, blizzards, severe thunderstorms to flooding, is our responsibility to issue the warnings and advisories.
Okay. So was it you guys or another portion of the weather system that had the most tornado warnings last year?
It was us, yes. We had 73 confirmed tornadoes in our area. Normal for a year is like 19.
So a lot more than normal.
Yep, and our highest previous to 2024 was 37.
Oh, wow.
Yeah, so we were quite busy. I combed this whole area, probably every section line in this county, looking for tornado damage.
Okay. So what goes into that when you're looking for tornado damage? Is there specific things that you look for compared to a straight line wind as opposed to a tornado?
Yep, so after the event, we have to go basically become structural engineers. So if the tornado doesn't hit anything, let's just say it stays in an open field, doesn't do any damage, there's no crop growing yet, it's really hard to rate the tornado. And it might be an EF, what we call unknown. It doesn't mean it didn't happen, it just didn't hit anything, and that's this whole scale of the enhanced Fujita scale. So once it hits a property, then we can really go in and see how strong the winds were based on the damage it did. So we have degrees of damage for a damage indicator. Maybe it's the farmhouse. Mm-hmm. So we'll look at how the house is sitting on and bolted to, or maybe not, the foundation, and the damage that has occurred. So, outbuildings, they're not structurally as sound as hopefully the house. So a lot of outbuildings will find a ton of damage at. Trees are very helpful as well, but what we're looking for is essentially a narrowish path. Tornadoes can be anywhere from 50 feet to 2 miles wide. So very rare are they 2 miles wide, mm-hmm. but they can be very narrow, so then it's hard to sometimes find that damage. And so what we're looking for is a consistent track. Did the tornado lift, or is it a continuous track? And if there's 2 miles in between where we don't find any damage, then we have to call it two separate tornadoes.
Okay.
So that was, on Arbor Day tornado outbreak, that was a real struggle because it started southwest of Lincoln. The Elkhorn tornado did, and then ended up being the Waverly tornado. And that same cell traveled all the way up into Elkhorn, mm-hmm. And had cycled a couple times before it dissipated by Fort Calhoun.
Okay.
Yeah.
Yeah, and that one, we've had more, it seems, extremely long track tornadoes, especially last year. Mm-hmm. And so with you guys covering 38 counties, what's that day look like to you guys having to manage it and not only protect and keep informed for the people in the immediate path, but like, hey, an hour and a half down the road, you guys need to be watching out too.
Yep. So our preparation starts days before.
Okay.
So we're looking at the severe weather outlook. For example, today we're looking, several days in advance, seeing when we have to surge our staffing. Because we are 24/7, we can move people's schedules around a little bit so that we can surge when we need to. So yeah, leading up to the event, we are having webinars with our partners, core partners, a lot of different agencies, FEMA, NEMA, Department of Roads, school superintendents, all the players that need to know, for public safety, what the forecast is. And we do the same for blizzards and any winter storm, flooding. But this was a big anticipated tornado day. So we had all hands on deck. And every workstation we had was full. And so I was off, supposed to go to a wedding in Fort Calhoun. And saw what was going on, and there was no way that was happening. I went right into work. But yeah, we sectorize those 38 counties. So we'll have one meteorologist watching, let's just say maybe north of the Platte River. It just depends on the storms, how they've initiated, and their expected movement. And so we'll split the area up. And then if there's a particularly strong tornado that's moving into a populated area, we'll just stick one forecaster on that storm.
Okay.
And then they have a team of folks who are communicating. We have people pulling in data from reports from social media, Twitter and our X and Facebook. And then we have phone calls going like crazy. And so then we have a wall of TVs where we have our local news channels up. And so if we're, looking up by Norfolk or up in northeast Nebraska, we have an antenna. We'll turn on the Sioux City stations and Lincoln for, and so forth. But we have, just for our situational awareness, we have a wall of TVs with all the local stations just on mute. And someone's watching the whole scene, like an incident commander, kind of like a NASA, when you see a NASA control center, but there's someone making sure everything's flowing. And it's just controlled chaos. We were at the point where we were issuing tornado emergency. That's the worst it gets. That's when you have a confirmed tornado about to go into a populated area. And so we save that that's the big guns. That's what we save. And we ended up issuing that for Elkhorn and for some of our families that were underneath said tornado emergency. So that was a whole new level of just hard. It was hard. But we did it. And we lost no lives in Nebraska.
Which is amazing considering the size and strength of that tornado.
It was huge. So, we forecast the event and then we go through, and the days after we're trying to find out the strength of the tornado, the width of the tornado, how long it was on the ground, all those things. And talking to the folks, they just did the right thing. They knew what to do. Some of them waited a little too long, and they in hindsight realized that. Some folks were out trying to save the animals out in their yard, and ended up diving under, front porches or some sort of structure. But it was a day I will never forget.
So you're saying don't wait to stop recording until the neighbor's house is gone. Get in the basement before then.
What I learned of my 26 years of doing this from just last year alone is that we have the warning out, hopefully in advance. Our goals are 13 minutes in advance of the tornado. And we try to warn before it hits the ground. That's the goal. But those people that are under the warning that don't get anything are lucky. They're fortunate. At some point when the tornado develops and touches down, someone's the first to get it. So if folks are waiting for that confirmation that there is a tornado, maybe they're watching TV, maybe they're looking outside, not everybody's going to get confirmation. Someone's going to be first. Kind of like a lightning strike. There's always a first one somewhere that's not showing up on your app. So learning too this year that there's a delay. So if you're watching, a storm chaser streaming on YouTube, or you're watching your favorite news channel and they're showing you the footage on their phone, or you're watching their footage on their phone, there's a delay for the communications to say, hey, there is a confirmed tornado, and then for the channels to get everywhere for you to get that there is a tornado. So there's a delay. It could be 5 seconds. It could be 30. It could be a minute. So seconds save lives. The Waverly tornado started southwest of Lincoln, went all the way through Lincoln before finally dropping on the northeast side of town. And in 90 seconds, it went from just touching down to an EF3 tornado that struck Garner Industries.
Wow.
Where 73 people were there. All of them lived by a miracle of the safety officer and the folks in the plant, but 90 seconds.
That's a huge difference from an EF0 to an EF3 in 90 seconds.
Just even, hitting the ground, it was tiny. And then, 90 seconds.
That's amazing. Just the power of the storms,
Yeah.
especially last year. And I'm from Iowa, so I look at the Greenfield tornado. Even though it was an EF4, it was the strongest wind speeds ever recorded. And looking at the videos of that, it's crazy. And luckily, everybody seems to follow the warnings after that.
Yeah.
And then, so moving on, we're here to talk about the outlook for the forecast for this year. Kind of a hard job to ask you to predict the unpredictable. But what are you guys thinking is going to be our long-term track for this growing season?
Yeah. So let's start with now.
Okay.
So we look at the equatorial Pacific, so way out in the Pacific Ocean along the equator. And that really has, I'm not a climatologist by any means. I forecast out the next 7 days. So what I'm talking about is referring to what my colleagues in the climate realm look at daily. And so all of those, there's several conditions that, translate into weather patterns. And so what we're seeing is we're going from a La Nina to a neutral pattern. So what does that mean? Well, we're looking at, for April, planting season, I would imagine, right? The temperatures are really difficult to determine. There's several factors coming into play. So they've left us in what's called equal chances. Now, it's going to be warmer to our south. Odds are tilting warmer to our south in the southern plains and the desert southwest, where confidence is greater down there. But for everybody on basically the northern half of the United States for April, the temperature outlook is equal chances. Equal chance of below, above, or normal. So that's not very, what do you want to say? It's not very definitive, but that's just the game of predicting climate patterns. So the precipitation-wise, again, we're in equal chances. There's much more signal that there will be higher precip to our, like around the Great Lakes area.
Okay.
A lot of it has to do with, you've heard of the polar vortex? Yeah, so that's stratospheric warming. It's breaking down. What does that mean? Well, we could get some cold shots of air from the Canadians. And so that's going to play into the temperatures a lot. And then whatever pattern you get with disturbance coming across really is going to influence our precipitation. So when we go from that's just April. And if we look at April, May, June, the 3-month outlook, we are, I believe, are we getting warmer? I'd have to look offhand, but it's looking like drier conditions will continue. That doesn't mean we won't get a rain, shots of rain here and there, but every drop counts at this point when we're going into the planting season. So they don't really have a real good signal on what the pattern's going to be.
Okay.
If that's helpful, probably not. I don't know. But it is what it is. Like in an El Nino where, you get hot and you have this dry pattern, it's more of a slam dunk. And as we change phase, it's really, really not a slam dunk for us.
Okay. So we're just somewhere in between the La Nina and El Nino.
Correct.
And we're just trying to figure it out. So what would be a year that we've had in, I don't know, the past several decades that set up similar to this?
Oh, I didn't do my research before I came. You know, I don't know. I would have to look that one up. I apologize. I again, I'm a 7-day forecast tornado warning kind of person. So yeah, I don't know the answer to that. I know that we in some of these transition years they can be very active in severe weather wise. But yeah, just having that, knowing that cold air push to our north can ooze down across the border, you know, leads me to believe, you know, we could have some more active weather than not.
Okay. Perfect. So when you're looking at the 7 days out, obviously the 7th day is a lot harder to predict than the first day.
Yes.
So how does your competency change based upon that 7-day lookout? Is it we're 95% sure on tomorrow, because we're never 100% sure.
No.
And then the next day it's a little bit less. And yeah, how does that work for you guys?
Yep. So in the nearer term, we call it, you know, the next 24 hours, we're pretty good on confidence wise. So what we're doing is we're sampling the atmosphere. We've got all the tools. The satellites are watching the systems that have come on shore, and we're sampling the data with observations across the country. So in the next 12 to 24 hours, we're pretty good, and we have a lot of computer models. I'm talking hundreds. You know, someone on TV might show like one or two, but we're looking at hundreds of forecast models, and they're essentially every hour. We get a solution for every hour, and every hour we get an update. So it just keeps going through. As we get into the medium range, we call it like days 3 to 7. That's when we start to get a little more spread, we call it, between the models. So if all the models are coming together with the same solution, we have high forecaster confidence. Hey, we're pretty confident this is going to happen. It's a good feeling. But when the models have a lot of spread between them, we're like, oh, forecaster uncertainty is high. And we let our partners know that. We're very upfront in our social media graphics with how we're feeling about this forecast. We're not real confident on temperatures, but we might be confident that it's going to have a lot of precipitation.
I think you see that a lot, especially with hurricanes, and they show all of them and 100 of them go in all different directions.
Yes.
It's like, okay, so you don't know what's going to happen.
Yep. And sometimes the old timers will call it a spaghetti plot.
Okay.
And it's exactly what it looks like, all these waves, and then you get so many different variations of it, and it just looks like spaghetti noodles all over the place.
So the big 3 models, would that be the Euro, the American, and then is it the Asian model?
There's the European, the American model, and then we have the United Kingdom, the UK Met is another big one. Now, they're running 50, I think the European model has 50 runs of it. And then what you see on TV is the mean of all of those 50 runs, but we can see each individual run and different formats, and we can see, you know, which one's producing snow, which one's producing rain, how much, and the variance in all the models. And so we do that, and we compare with the American and all the others. There's some models that are global, that cover the whole Northern Hemisphere. There's some models that just focus on, you know, their particular area. And as we get closer in time, so say it's the next 5 hours, that model will be in a domain of just maybe the Central Plains. And so you're really zooming in and getting a smaller grid spacing the closer you get in time.
Not necessarily less data, but more localized data, just more intense.
Yep. And the models that the researchers have been throwing together for us are just amazing when, for thunderstorm development, where exactly the thunderstorms will develop and then progresses. I think one of our experimental ones gives us every 10 or 15 minutes.
Okay.
Yeah, so we can see the progression of the thunderstorm. So it's getting really good. It's not, an exact science, and we're not quite there yet, but it's getting pretty amazing.
Do you think AI, as we go along with all the data that it can process, it processes way more than we ever could. Do you think that's going to really help solidify and make better models as we go?
Oh, yeah, 1,000%. We're already using AI and machine learning. So the machines are learning from the conditions that it forecasts and what actually happened, and it's getting really smart.
Okay.
Yep. So through my 26 years, the forecast has been more hands-off now as far as, the days like 3 through 7. The models are doing most of that, and humans can't really improve on most of it. Mm-hmm. So we just, kind of let it go. And they're doing a fabulous job. The really important part, the next 0 to 24 hours is what's really important and still takes that human intervention. Because models don't pick up on everything. There might be more moisture over, the Gulf of Mexico coming up, and it just doesn't catch on to it. So it just depends on the situation. They are getting better, but we still have that human intervention we're going to need for a few more years.
Okay. Well, at least you got a job for a while.
Well,
yeah.
I guess.
So I know the last few years haven't really represented it, but I remember as a kid that as the storms would start somewhere in Nebraska and then just come over to the Missouri, and then after that, it was a crapshoot on where it went. So is there something with the Missouri River that affects the storms that causes some turbulence or anything with it, or any large body of water?
Sure, yeah. A lot of it has to do with, so Tornado Alley has a lot to do with where the Rocky Mountains are, as well as the Gulf of Mexico. So those are our main drivers in Tornado Alley. And it just depends on the system coming across the Rockies and how much moisture you're getting up from the Gulf. And then in addition to that, if you have colder air in the northern plains too. So, I've heard stories where, I've never seen a tornado cross a river. I've seen plenty. I can show you a case after case where they do. But, we get a lot of convection popping up in the high plains during the heating of the day, and then those sometimes continue all the way east through the night, and then end up this big bow echo of storms over, Des Moines area toward dark. So it just depends on the time of day and when you really get the thunderstorms to start developing, and just how the system's all coming together. Yeah.
Okay. And then with cities, like you look at Omaha, you look at Des Moines and Sioux City, that pavement holds a lot of heat. Mm-hmm. Does that play into an effect where the outside ground is cooling, but this city center still holds a lot of heat that it can kind of help re-spark a storm or anything like that?
That's interesting you ask, because there's some studies. Actually, Dr. Houston down at UNL is flying drones into pre-storm environment, so before the thunderstorms occur, and he's working over what we call that urban heat island. Mm-hmm. And so we've... to back up a little bit, we've done some research on how the urban heat island in the Omaha metro is. So the eastern side of Omaha, where it's mainly concrete buildings, versus the western side of Douglas County. So you're more green space, right? So they found on one of our hottest days in, I believe it was late July or August of 23, it's 8 degrees hotter in the urban center than it is in the green space out west. So Lincoln, they're hoping to do that study soon, but what Dr. Houston is doing, and I took this study down to Tulsa. You can't just fly drones into a city and nobody cares. You have to get a lot of permissions, and so UNL's gone through great strides to fly these drones into the environment before a thunderstorm comes in, to see what kind of heating, what kind of increase, if there is any, there might be into ingesting into that thunderstorm. So it's very complex, and they don't have results, I don't believe yet, or at least I haven't seen them. But I'll be very curious to see how all of that kind of plays together, because we saw that cell go right over Lincoln, never dropped a tornado, thank goodness. And then got to the northeast side, and some cells to the southeast just came and ingested right in there. And that's when that Waverly tornado really spun up. Mm-hmm.
And I've always seen it with, like, the Des Moines Metro. It kind of seems like storms come over, they're not that bad. But by the time they get to the other side of the metro, they're starting to pick up in intensity.
Yeah. So there are researchers looking into that. That's interesting you bring that up. Yeah.
Sweet.
Yeah.
Well, I'm glad I was on to something.
Yeah.
Yeah, so anything else you want to cover for our lookouts, anything like that?
It's just, we've lived here a long time in the Central Plains, and Our some of our rainfall events especially have been bigger and shorter. So what I mean by that is, the amounts of rain, like we had the 18-inch rain up by Sioux Falls last summer. And that had a big impact downstream eventually when the Missouri River flooded. And so we're seeing some of these events, although we have really dry periods of, growing season days, then we get a system through and there's just so much moisture to work with that it just dumps rain. So, anything, if you have a rain gauge and you're keeping track of the rainfall, that's really important for us to know just how much water is really out there, how much has fallen. Our radar can help us kind of see an estimate, but if there's any hail in the storm, that contaminates the rainfall data.
Okay.
So any hailstones in that data really just mess with our rainfall estimates. We call it just hail contamination. So if folks have, their own weather station and it's hooked up to the internet, we can see that. Otherwise, there's a website. It's called CocoRaws, and I can give it to you later. It's weird, but it's free, and it keeps this really cool database of your information. And we use it for Drought Monitor, too. Okay. So we use it for both. I'm a terrible observer at home. I'm supposed to report zeros every day. It doesn't rain, and I don't, but whatever.
If blank, it's zero.
Yeah, that would be good. Yeah.
Yeah, and one thing I've seen too, there's a couple farm systems where it does the satellite, you got this much rainfall. Well, especially with how dry we are, it seems the atmosphere takes its first, and it might say you got an inch, but really only a tenth fell.
Oh, dear.
Yeah, so some places were pretty bad. And and now when we're going into this season, it's predicted to be dry is what I've been seeing. So the old saying is drought begets drought. How true is that?
There is some truth to that. And my hydrologist at the office, he always says a drought's always busted by a flash flood.
Well,
so careful what you wish for. Slow and steady wins the race here, but we tend to get those downpours that just run off and.
Especially like with that 18-inch rain you just mentioned, in a place where you get 24 to 26 inches of rain and it comes in one day at 18.
One day,
yeah. That creates some problems.
I know, and just seeing those numbers, from just a forecaster perspective, you're like, what? Is that still sitting there? And and you got the flash flood warnings out and everything you can do to warn the people downstream. But it's just crazy to see that kind of water just come out of the sky.
Yeah, that's a lot of water.
Yeah.
Definitely. So another one I've seen recently, and I want to know how true it is when we see a percentage of rain, it's not the percentage of if it's going to rain, it's how many people out of 100 actually will see rain. Yeah,
so the probabilities, they have been confusing since they began, I believe. So what we're doing is we're giving folks a probability of, let's talk snow for a minute. So and you move snow for a living, and 2 inches of snow is what's in your contract. So your client says, hey, I need you to be out here moving snow if we have 2 inches. We're giving forecasts in a probabilistic manner now, such that we can say you have a 50% chance of seeing at least 2 inches of snow. And then we'll say you have a 40% chance of at least 4 inches of snow. And then we just keep going. And we might say there's a 1% chance you're going to get 10 inches of snow. And so my older kids move snow for a living. And it's been very helpful for them to, okay, what are the odds that we have to move snow tonight? So that has been super helpful. We're giving ranges. People understand probabilities to that degree. Like, how does that impact me? There's a 60% chance of rain. Well, there's a 40% chance it might not rain. But the odds are better that we have a 60% chance of rain. So it used to be aerial coverage. Now it's a probability.
Okay.
Yep. So you have a 4 out of 6 chance, that it's, or 4 out of 10 chance that it's going to rain. 6 out of 10 it won't. Does that make sense?
Yeah, definitely.
It can be complicating, And we're even doing that with temperatures now. So folks that are really sensitive to the heat, like livestock producers, will say, hey, we've got a 90% chance that we're going to see heat indices of over 115.
Okay.
You know, and that just allows people to plan accordingly. And everyone has a different threshold. So we found from studies actually that customers prefer that.
Okay.
So instead of giving you a finite number that it's going to be 90 tomorrow, that might not be good enough for everybody. So we'll say, okay, there's this range of possibilities between 89 and 95. So that, something like that. So we do that with almost all fields now. Everything we forecast are probabilities.
Okay.
Yeah. They're hard to explain to just the average person, but I think once you put it in perspective of how does it impact me and do I have to go move snow? You have a 90% chance of getting 2 inches or more. Yeah.
Okay. I can say my heat prediction when I walk out of the house at 6 a.m. and it's already 80, I know it's going to be hot.
Yes. You break a sweat when you walk out of the door. Yeah, that's the worst.
From the house to the truck, if you're sweating, it's going to be a war.
It's going to be bad. It's going to be bad, yes. And that's another thing, too. Our dew points, the amount of moisture that we hold in the boundary layer have really increased. I've seen more dew points in the 80s, which is an incredibly tropic environment that we have here. Essentially June, into sometimes through like fall football, even when those early games, they're out sweating like crazy on the field. We work closely with the NSAA, the Nebraska State Athletic Association, and have come up with some guidance for them, so to keep players safe, cross-country runners and softball players and so forth. So the athletic directors have some rules that they have to follow when it comes to player safety and heat.
Okay. Yeah, that's probably a good thing. I remember the 2 days when it was 100 degrees out, so those were never fun.
No, and you might have a kid that stayed in their mom's basement all summer and isn't acclimated to it, comes out, puts full pads on, and then they go down. So we're trying to help those folks out, the athletic directors, so that we can prevent some of those issues.
So we already kind of mentioned it before, but with the Gulf of Mexico, with the Rocky Mountains, would you say that where we are in the Midwest and almost the Upper Plains, that we are one of the most unique weather systems in the world just because of the variability of it?
Oh, yeah. Tornado Alley. I mean, we are the place that storm chasers from around the world come to in the spring. You've seen them, on social media or on TV. This is the area. This is where they go. And it ranges, from Texas all the way up into the Dakotas, mainly on this eastern side of Nebraska and the Dakotas and Kansas. The other thing that makes this a good place for storm chasers is that there's not a lot of trees and, things that would block their view. Like the Deep South has, is just trees and hills, and so they can't see much. Yeah. So it's dangerous to chase there. But yeah, we in the plains here have a very unique part of the world. And
especially in the Deep South, they get their storms at night.
Yes, and they're very deadly. The tornadoes at night are, oof.
Yeah, not a good thing.
Not a good thing. No.
Perfect. Well, anything else you want to cover?
I don't know.
Anything we missed?
I don't think so. Yeah, I think unless there's something you're dying to know.
I think we covered it all. Perfect.
Sounds good.
Perfect. Well, thank you for your time. Look forward to hearing you later tonight.
All right.
And thanks, everybody, for listening to another episode of the Red Effect Podcast. The Red Effect Podcast is brought to you by Red Star. Red Star, where our red makes you green.